All right, moving on to number 2 in 11.6. At this point, we have a quadratic given to us. We spot this squared term here, and so this is a quadratic, and we want to first get it into this form. That's step 1, and then it says factor it into 2 linear factors. So what that means is factor this, all right, by the skills we learned in this chapter. So we learned that if there's a negative up front, we want to pull a negative out. And we can see a common x here. And we also see that these are both even. So we have a GCF of negative 2x in this problem, and we're going to pull that out front. So I have negative 2x. Left in my parenthesis is 7x plus 2. Remember, we get that sign change because we factored the negative out. Okay, so now we can see that this problem is very much like one that we just worked on previously, part B. Part B, we had this already factored, and we broke it into 2 pieces, and then we found our 2 solutions. Okay, so what I can do here now is step 2. It says solve the quadratic equation by factoring. Okay, well, we have it. I would maybe like it to say solve the quadratic equation by factoring and using the ZPP, zero product property. Okay. So we have it factored, and I'm going to break it apart here. Negative 2x equals 0. 7x plus 2 equals 0. So on this first one, I divide by negative 2, and you probably already are getting the hang of this, but this one yields x equals 0. And then on the second one, I'll move the 2 over, showing slightly different technique here. So it's minus 2. I have 7x equals negative 2. Divide by 7, and you probably already can spot the answer. But we have 4x equals negative 2 over 7. Okay. Didn't get those lined up perfectly, but I think you can see the answers there. Okay. And now let's look at one more here. Maybe we can do a couple more in this video, but this should look familiar to us. You know, the first thing I notice is, hey, 25 is a special number. It's a perfect square. I already have this set equal to 0, which is great. 9's a perfect square. It's 3 times 3. So I got 5x and 5x. I got to get a minus in this problem, so I'm going to put minus 3, minus 3. And then I notice that my 2 linear factors are the same. So if I set this equal to 0 and set this equal to 0, I get the same thing. So I only need to solve one of these. So I'm going to move the negative 3 over and get positive 3. So I have 5x equals 3. Divide by 5, and x equals 3/5. Okay. All right, looking at C here. Get my paper arranged. We're taking a look at C. Hey, 25 is a special number. Let's see. Let's try x and x, 5 and 5. To get the 25, I got to get a minus sign in the middle, so I'll use double minus here so I can get the positive 25. Right, equals 0. And I see it's a lot like problem B, where I really only need to solve one of these. And when I do that, move that over, I get x equals 5. Okay. So if it's a match, we don't have to say x equals 5, x equals 5. We don't have to say it 2 times, okay? Now looking at D here, we have to be careful with this, all right? It is not ready to factor yet because it doesn't say equals 0. So what I'm going to do is I'm going to add 5 to both sides, or move the negative 5 over, okay? And I have 45 x squared plus x, and then minus 2 equals 0. Okay, so I'm going to factor this. The first thing that comes to my mind with 45 is 9 and 5. Now that doesn't mean it's going to work because there's other options. There's 3 and 15 and 1 and 45. But if I start to play around with this a little bit, I realize that if I put the 2 here, because I got to get 2, that would produce 10. If I put a 1 here, that would produce 9 by FOIL in our factoring techniques that we've been using this chapter. So I'm going to put the positive here and the minus here because that'll produce a positive 10. Let's just look at this. Outside and inside. Outside is negative 9x. Inside is 10x. And I need to get a positive x. So I have this factored correctly. Okay. So let's try the shortcut technique on this one. Change the sign on this. Okay, so I'll bring that down. Negative 2. Put it over the coefficient on the x term. Or change the sign on this. And remember, this all comes out of the solving that we've seen in the previous problem. So change the sign on that. So that's going to be positive 1 over 5. Remember, we don't change the sign on the coefficient that's in front of the x term. Okay, it's just the denominator of our fraction. Okay, but like I always say, set each piece equal to 0 and solve if you don't understand the shortcut. Okay. All right, that wraps up the first few. Number 2, we'll look at a few more. Thanks.